This is Unit 4, Similarity. Preview video 4.4, Similar Applications. Sit tall. Ready? Take a deep breath. Inhale through your nose. Hold. And slowly exhale. Don't forget date, time, and location, as well as a parental sign-off or guardian sign-off, affirming that you did this yourself. You're going to need a calculator handy at some point today, so make sure that's close at hand. There are two main goals for today. We're going to review triangle shortcuts. Triangle shortcuts, similarity. Two triangles which have congruent angles and side ratios equal. And now we're going to apply triangle similarity to practical applications. So number one, we're going to review triangle similarity shortcuts. Two triangles which have congruent angles and side ratios which are equal. So what are the shortcuts to SCARE? There's three of them. One is angle, angle, where you have two angles in one triangle, and which are congruent to two angles in another triangle, corresponding angles here and here. That would represent angle, angle similarity. Then we have side, side, side similarity, where you have all three sides in one triangle proportional. And remember, proportional means equal ratios. Doesn't mean equal sides. So for example here, short side 3, long side 6, left to right, that's a 2-to-1 ratio. And we have medium side 8, medium side 4, left to right, that's a 2-to-1 ratio. Long side 10, long side 5, left to right, that's a 2-to-1 ratio. So the ratios are 2-to-1, all three of them, all the way around. Therefore, this would be considered side, side, side similarity. Side angle side similarity says if you have two sides in one triangle which are proportional, for example, short to short, left to right, 2-to-1. And then you have proportional to two sides of another triangle, 8-to-4, left to right, 2-to-1, with an included angle, or what we will call a squeeze angle, because it's squeezed between the two sides. And that is going to constitute side angle side similarity. Remember, what's the purpose of shortcuts to similarity? All of these shortcuts get us to congruent angles and ratios which are equal. This is the magic ticket to solving the next problems. So let's do a quick review of the shortcuts. We're going to determine if the triangles are similar. If they are, state the shortcut, then complete the similarity statement. So first what I'm going to do is when you have overlapping triangles, it's important to pull them apart. careful there. This is not 39. You have to add 39 and 13. All right, now we do have a shared angle, an included angle right there. So we have an angle. Now we're going to check for side ratios. Side ratios. 12 and 48. 12 goes directly into 48 4 times. So it is a 1:4 ratio. 13 and 52. 13 does go into 52 4 times. That's also a 1:4 ratio. So that gets us a pair of sides and another pair of proportional sides, not congruent this time, and an angle. So these are similar by side, angle, side, similarity. Now you just have to follow the order. HGF. HGF is therefore similar to HQR. Notice the direction, HGF, HQR. Taking a look down here at this one, we'll do this one together. Once again, we have overlapping triangles. When we have overlapping triangles, you want to pull them apart. Entire side is 70. Careful there. This is not 48. It's 12 and 48 is the whole side here. Be very careful with that. Physically trace it. Now we're going to check. First off, we do have an included angle, a reflexive angle. So we do have what we would call an angle. Let's check our sides here. 13 and 70. And 12 and 60. Well, 12 and 60 is a 1:5 ratio. And if I do 13 times 5, this should be 65. It is not. So the proportions do not match. If the ratios do not match, they are not similar. This shortcut you're going to do all by your lonesome. Pause the video, restart when you're finished. All right, grab your red pen, folks. I expect to see corrections, star smileys if you're correct, a little note in the margin if you're not. So let's see what we have here. First off, we have parallel lines. Because you have parallel lines, you're going to get a pair of corresponding angles. You also get another pair of corresponding angles. They also have a shared reflexive angle. Technically, this is angle, 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 but when we're talking with shortcuts, you're always looking for the absolute minimum. So the absolute minimum here required is simply angle, angle, similarity. So yes, they were similar, and now you have to trace it, and we have RQP, RQP, so that would be RUV, triangle, RUV. There's your shortcuts. You must be familiar with all three shortcuts because now you are going to apply triangle shortcuts to practical applications. Practical applications. You're going to apply triangle shortcuts to practical applications. All right, let's take a look here. You have 2 pages. So first we're simply going to read and attempt to draw. Put your finger there. I want you reading with me, folks. Out loud, finger on the paper. Out loud, finger on the paper. Ready? read. Sean wants to measure the height of a large sequoia tree at Big Sur National Park with only a tape measure. Ambitious young man. On a sunny day at 3 p.m., a friend measured Sean's shadow and found it was 3 feet 9 inches. In length, Sean's height is exactly 6 feet. The tree's shadow is 84 feet. Find the height of the tree. So we're going to be very careful to draw, label, list, cross out. So here we go. We have here, well, we have a young man named Sean. So let's draw Sean first and Sean's shadow. Okay, Sean's shadow, Sean. So here's Sean standing, and they don't say whether or not the shadows are overlapping, so we're just assuming he's standing to the side of the tree. So Sean is 6 feet in height, and Sean's shadow, and you can assume all shadows to height, they're at a right angle, is 3 feet 9 inches. So in my storyline, the way I'm drawing this would mean the sun's like about here. Kind of keep track of the sun. It's important that you understand shadows always face the same direction. Okay, if the sun is here, shadows are always going to go this way. Okay, so keep that in mind. We're dealing with one sun. If you have two suns, like your Tatooine, or I think it was 3, I'll have to rewatch that, you can have multiple shadows going different ways. But because we only have one sun, all shadows are going to go the same direction. That's kind of important. All right, and then let's see here. We got the shadow, Sean's shadow. The tree's shadow is 84, that's feet. Let me keep my color straight here. Tree's shadow, 84 feet. Doot, doot, doot. 84 feet. And we want the height of the tree, which we are going to call X. Now watch very, very carefully. What we have here are 2 triangles. And what we know are true about these triangles is a couple things. One, anything built against the ground, we're going to assume that there's a right angle. Okay, so first off, we have a pair of angles. Now, when you're dealing with shadows, the angle back up towards your sun, if my sun's here, the angle back up towards the sun is always going to be the same degree angle. So this angle here will be the same because our sun's behind the tree. So we know that these triangles are going to be similar by angle similarity. That's important because if they're not similar, you can't do any of this proportional stuff. So because they are similar, then you can do all this lovely proportional stuff. So I'm going to pull this over to the next page. Alrighty, so there's several ways you can do this. You can do it height to height, shadow to shadow. You can do it height, shadow, height, shadow. You can do it shadow to height, shadow to height. The name of the game is match the sides and mirror whatever direction you're going to go. Match the sides, mirror the direction. So I can go like this, 3 feet 9 inches to 6 feet, 84 feet to unknown. Or I'm going to go height to height, left to right. I'm going to go 6 feet to unknown is the same as shadow to shadow, left to right. 3 feet 9 inches to 84 feet. Now, let me keep my color straight. We did that in green. we got an issue here. We have a discrepancy in units. We have feet and inches. And you cannot have mixed units. We already talked about that. So I'm going to show you how to set these both up. And in one style, we are going to go all into feet. Another style, we're going to go all into inches. You're going to get the same answer regardless, but I want you to see both styles. So here we go. Come back to this calculator in just a minute. You're going to need your calculator handy. Most of you aren't going to want to do this longhand. So first we're going to do all feet. So 6 feet is just 6 feet. There's nothing to mess with there. And this is going to be unknown. I'm going to put the notation that I'm working in feet here. Now here comes the fun part. You know, yay, American system, it's a base 12 instead of a base 10. So watch carefully, guys. You don't want to get this wrong on a test. 3 feet, 9 inches is not 3.9, friends. No, it's not. Why is it not 3.9? Because 0.9 is a base 10 decimal system, and 9 inches is a base 12. So, therefore, we have to convert the 9 inches, put it over base 12. Okay, 3 goes into 9 3 times, 3 goes into 12 4 times, and now to convert to a decimal, just think in money. Most of you can easily think in money. So what is 3/4 of a dollar, or 3/4? Most of you think in money, quarters. Now you got it. It is 3.75. Ta-da! There you go. Feet, there's your decimals, and 84 feet. Now you're 100% in feet. Now we're going to go the other side into inches. So to do 6 feet, that's going to be 6 times 12, of course. And this is 72 inches. Watch your units. Here, when we compute this, it will be in inches, which means we'll have to take it back into feet and inches. 3 feet is 3 times 12, which is 36 inches, plus 9 inches is going to get us 45 inches. And then over here, we're going to do 84 times 12 longhand, because you're so amazing at your 4th grade math. Okay, now we cross multiply. We'll do both. All right, so this is going to, I want you to get X all by its lonesome, then you can grab your calculators if you choose to. So this is going to be 6 times 84 equals X times 3.75. So if I were to get X all by its lonesome, I divide by 3.75. So I'm going to have X equals 6 times 84 divided by 3.75. Now that X is by itself, now you can grab your calculators. You can do it in one step. Well, everything just disappeared on me. All right, let's do this real quick. Okay, that is I'm just going to do the feet now that we did all our translation here. So set the proportion back up. We were at 3.75 over x. Excuse me. Nope. That's 3.75 over 84. If I'm not mistaken. Yep. Equals 6 over x. And we're doing this in feet, cross multiply. That's where we're at. And if you isolate x, it's going to equal, let me keep it color coded here, 6 times 84. This is all in feet over 3.75. Now, you can get your calculators. Get x by itself, and we're going to do 6 times 84, 504. I'm going to divide by 3.75. We get 134.4 feet. I'm going to show you how to go back into feet and inches because I'm going to want to make sure you can do that. So this is 134.4 feet. To get this portion back into inches, this is what you're remembering. That 4 there is a base 10 and inches is a base 12. So you are thinking like this. And it's going to be 4 times 12 divided by 10. That's the long way. I just want you to see the proportions there. And then I'll show you a shortcut that you're going to like, why didn't you just show that to me to begin with, Miss Way? I want you to see it's still a proportion, base 10, base 12. So 4 times 12, and then we're dividing by 10, gives us 4.8, so that rounds, because we went the nearest whole inch, to 5 inches. Or you can simply do this. Watch, take the decimal, which was 0.4, and times by 12 inches. So what is 0.4 of 12 inches is 4.8. So it is approximately your final answer here, 134 feet and 5 inches approximately. You need to be able to handle back and forth. Now that you have the inches as well, and you just cross multiply, then you divide by 12 and get your back into feet. Let's do one more together, and then you're going to do one on your own. But I need to introduce to you something called a reflected angle, not a reflexive, a reflected. This only works with mirrored surfaces, such as an actual mirror and a water surface. So a reflected angle is when light goes into against a mirrored surface, it bounces off that surface at the same angle. That's why you see the same thing. Careful, these are not vertical angles. That would be the angle of incident and the angle of reflection. These are congruent. You can see it this way. Light comes against the mirror, bounces off the mirror, and that angle off the mirror is going to be the same for both. That's an angle of reflection. It's not a reflexive angle. It's not a shared angle. Got to do the light dance. All right. So using this application, legend has it that if you stare into a person's eyes in a special way, you can hypnotize them into squawking like a chicken. Here's how it works. In the diagram below, Ricardo is 6 feet 3 inches tall and is standing 3 feet from the mirror. And once again, anything that is against the ground we can assume is a right angle. If the chicken victim is 5 feet, 4 inches tall, how far is she standing away from the mirror? This would be your X, and of course there's a right angle. Now, why are these triangles proportional to begin with? Because you cannot use a proportion unless they're similar to begin with. And we have right angles, which gives us one angle, and I just told you, since this is a mirror, this angle going in bounces off at the same angle. So once again, these two triangles are similar by the angle-angle shortcut. So let's translate this into feet totally. That's 3 over 12. And this is going to be 4 over 12. All right, I'm going to go height over distance. So that's going to be 6, and then 1/4 of a dollar is 0.25 over 3. See what I'm doing here? So I'm working height over distance equals height. This is 5, and then 1/3 of a dollar is approximately 0.33. And X is our distance, and our answer is going to be in feet. Do not touch a calculator until your X is by itself. So we have 6.25x equals 5.33 times 3. Of course, we're going to divide by 6.25. And x is now by itself. 5.33 times 3 divided by 6.25. Now that your x is by itself, now you may grab a calculator. So we do this. 5.33 times 3 equals, divided by 6.25 equals, and I get 2.56. So this answer here is 2.56 feet. I want that 0.56 translated back to inches. So we get our calculators up and going again. And we simply do 0.56, which is base 10. And we times, well, technically it's base 100 now, times it by 12. And we get 6.7 inches, and I'm going to round to the nearest whole inch, which is 7 inches. So how far is the hypnotized victim away from the mirror? The answer to that is 2 feet, 7 inches approximately. This page, I'd like you to pause the video, do it on your own, and then restart. Pause. Welcome back. Okay, students, red pens, you're correcting. You're not copying, you're correcting. That's super important. You're correcting, not copying. It says here, a cell phone tower is 300 feet tall. So here is our cell phone tower. It's 300 feet tall. And at 3 p.m. casts a shadow of 152 feet, 8 inches. So our shadow is like this, 152 feet, 8 inches. The building next to it casts a shadow of 78 feet 6 inches. So here's our building next to it, 78 feet 6 inches. And our goal is, how tall is the building? Once again, these triangles are similar by angle similarity. If we assume the sun's up here, then the angle towards the sun is the same. And remember, I told you anything built against the ground at a right angle, you have a right angle. So they are similar by angle similarity. You could do height over height equals shadow over shadow, height over shadow equals height over shadow. Whatever you did, you match the sides, mirror the direction. Let's see here. 78 feet 6 inches. I'm going to go shadow over shadow. 152 feet 8 inches. Shadow over shadow equals height over height. All right. Now, before we can do anything, we need to get this into decimals. So that's 6 over 12. This is 8 over 12. So your proportion should look something like this: 78.5 over 152.66. 6, 7, repeating is fine. If you did 6, 7, it's fine. Unknown height. So I'm going shadow over shadow, height over height. Small to large, 300. Don't touch a calculator until your variable's by itself. So you can see here that your unknown is basically going to be 78.5 times 300 divided by 152.66. Let's see how you did here. So 78.5 times 300. And then we're going to divide by 152.66, and we get 154.26. 154.26. To get that decimal back, we're going to do 0.26 times 12, and we get approximately 3 inches. So final answer here, you should have gotten approximately 154 feet and 3 inches. Ta-da! You should be writing with red pen what you did right or what you did wrong so you remember it appropriately.